Hello again, algebra students. Today we're going to continue on working with linear equations, but we're actually going to be graphing those linear equations. You did some of this already a couple of days ago on some table of values kind of work, and that's what we're going to be continuing with today. Sometimes when we see a table of values, they're horizontal like this. Typically, we like to graph them, have the tables going vertically because it's easier to see the order of pairs, whatever, but it's okay to also see them horizontally sometimes. So I think that you need some experience seeing it this way. In these two tables, I already have x's chosen that we're going to use and we're going to be substituting in. I would strongly suggest that you show some work on some of these. Sometimes we can just do them in our heads, and I will be doing some of them like that, but it does also help to show your work on some of these problems. In the first one, when x is -4, keep in mind what this really means. So I'm not always going to write, when I'm showing my work, I'm not always going to write the y equals part, but I'm really putting this -4 or any of those x values in for the x. So I would have half of -4. Okay, so that part in your head, half of -4 is -2. -2 minus 2 or plus a -2. -2 plus a -2 is a -4. If you're doing this on your own paper, then really what you're going to be doing is switching. Instead of a -4, you're going to put a -2 right here. That's going to get too hard to read if I just keep scribbling out every time. And like I said, I don't always write down the y equals part. I would want 1/2 of -2, which is -1. -1 plus -2 is -3. When I put in a 0, by the way, 0 is my favorite thing to substitute because it's going to make stuff easier. It makes stuff go away. When I do that, 1/2 times 0 is 0. 0 plus a -2 is going to be -2. When I put in a +2, again, if you were doing this on your own paper, you could just change this problem that's on top, change that to a plus if you want to. I think that's going to get too confusing up here. So we're going to say 1/2 of 2 is 1. 1 plus a -2 should be a -1. By now, you're seeing a pattern in the y's, and that's great. That pattern should continue. Please don't just depend on that pattern, because if you made a mistake somewhere in this work, then continuing on with the pattern that you see would just continue that mistake, and it would make it way far off. For the last one, half of 4 is just 2. 2, and I can even just do -2. 2 minus 2 is going to be 0. When I graph that, look at these like ordered pairs. Again, that's why I don't really like the horizontal tables, but this is an ordered pair of -4, -4. Remember, the first number, the x is always the sideways, so -4, and then down 4 would be right there for my first point. The second point is at -2, -3, 0, -2, 2, -1, and 4, 0. These are linear functions. If you are not getting a straight line to make them linear, you made a mistake. And if that happens, please go back and check your table and see what may have gone wrong as we're working on that. For number 13, this isn't written exactly in slope-intercept form, if you remember that from last year. And I would say I would still want to change that to plus a negative. But when I substitute in here, I'm still just putting numbers in place of the x. So for the first one, I would have 1 plus -2 times -2, right? The -2 was there already. I'm going to substitute in the -2 for the x. -2 times -2 is 4, plus 1 is 5. When I put in a -1, I would have 1 plus -2 times -1. And again, we have to follow order of operations. I have to do that part first. That's 2 plus 1 is 3. When I put in a 0, I'm going to have 1 plus -2 times 0 is just 0, so 1 plus 0 is 1. When I put in a +1, I'll have 1 plus -2 times 1, well, that part right here then is just -2. -2 plus 1 is going to be a -1. And again, you should be seeing a pattern in the y's. When I put in the 2, the positive 2, I'm going to have 1 plus negative 2 times 2. Well, negative 2 times 2 is negative 4. Negative 4 plus 1 is going to be negative 3. And that pattern does hold for the whole table. So negative 2, 5 is here. Negative 1, 3. 0, 1. 1, negative 1. And 2, negative 3. And that is linear. And as a preview for other topics that we're going to be covering, hopefully you remember that's a negative slope. This is actually a negative 2 slope. The first example was a positive 1/2 slope, if you kind of remember that from last year. Here we've got a table set up vertically, but I didn't pick the x's yet. By the way, on today's worksheet, the x's will be chosen for you, and added bonus, they won't be in a pattern. If the x's are in a pattern, your y's will be in a pattern. The worksheet does not have the x's in a pattern because I don't want you to just depend on that pattern. I want you to actually be substituting in these numbers and trying to figure out what this should be, not just looking for a pattern and trying to take an easy way out. I also didn't pick x numbers yet because typically, and maybe you'll remember this from last year as well, we would pick the same kind of numbers every time. Negative 1, 0, 1, and 2. Those were kind of our go-to numbers. However, in this problem, if I did that, when I'm putting in a 1, for instance, I would have half of 1 is half. Now I've got a kind of messy problem because I'm going to have a whole bunch of fractions, and graphing fractions are not easy. So I would rather pick my own x's, and that number right there is going to help me decide what to use. Because the denominator is a 2, I want to pick multiples of 2. If I'm going to pick a negative number, it's going to be negative 2. 0 is always going to be in my list. And then instead of like 1 and 2, I would go with 2 and 4, because when I substitute in those even numbers, finding half of an even number still gives me a whole number. And again, on the worksheet, those x's will be chosen for you. You don't have to pick them yourself, but I just want to remind you of some stuff. So when we're substituting in these new x values, remember those x values are going to go where that x is. So I would have 1/2 times the negative 2. I would just do this as you go. Do that step first, hopefully in your head, but use a calculator if you need to. 1/2 of negative 2 is going to be negative 1. Negative 1 plus negative 3 is going to be negative 4. When I put in a 0, again, my favorite, I usually don't even show work on the zeros because half of 0 is 0. 0 plus a negative 3 is just going to be negative 3. When I put in a 2, half of 2 is 1. 1 plus a negative 3 is going to be a negative 2. And again, you should be seeing the pattern in the y's. When I put in the 4, half of 4 is 2. 2 plus a negative 3 is going to be negative 1. And again, use a calculator if you want to. These numbers I think you should be able to handle in your head, but if you're at all concerned that you're going to make some mistakes, go ahead and grab your calculator. So negative 2, negative 4, again, remember the first number is always the x. We go sideways, so left 2 and then down 4. 0, negative 3, 2, negative 2, and 4, negative 1. And again, talking about what we just said on the last slide, that has a positive 1/2 slope, if you remember that. And you should be able to see that slope number in your problem. Okay, here's our last example. In the problem that we just did, we picked multiples of 2 because the denominator was 2. This time, our denominator is a 3. So I'm going to pick multiples of 3. If I have to pick a negative number, I'm going to pick negative 3. I'm always picking 0. And then 3 and 6 will work nicely with this. And again, I know that some of you see that fraction and you start getting nervous and you want to grab your calculator, and you certainly can. But because we're picking numbers that work really well with that denominator, it's not that bad. So when I substitute my negative 3 in here, I'm going to have negative 2/3 times a negative 3. I'm going to make it look like negative 3 over 1. I'm not even going to write the plus 1 yet. I want you to notice that this is going to be a negative times a negative, which is a positive. can even do that right now. And the 3 in the denominator and 3 in the numerator cancel. So this whole mess just turns into 2. Plus the 1 that was in my equation gives me 3. Next one is easy. Negative 2/3 times 0. Anything times 0 is 0. Plus 1 is 1. We already did this work just with the negative on the last, on the very first one in this problem. So let me do this. So the 3's are going to go away. This time it's a negative 2 because the negatives didn't cancel. Negative 2 plus 1 is negative 1. And again, seeing a pattern in the y's. Negative 2/3 times 6. This will be a 1. That'll be a 2. Negative 2 times 2 is going to be negative 4. Negative 4 plus 1 is going to be negative 3. So negative 3, 3, 0, 1, 3, negative 1, and then 6, negative 3. Again, this is linear, makes a nice straight line. And again, just thinking about this, down to over 3, I've got a negative 2/3 slope, which is that number right there, a little preview. Okay, so today's worksheet is a riddle worksheet. We're calling it the Zorna worksheet. After you finish that, there'll be tables on one side of the worksheet, and there's graphs on the back side of the worksheet. So you're filling in the tables and then graphing those to be able to make sure you've got linear and everything works out. There's an answer key in Schoology, and when you're done, take the formative quiz that's in Schoology. Let me know if you have any questions.